Hello and welcome back. I'm Data Science Dom, and today we will have a deeper look into artificial intelligence. So, have you ever wondered how Netflix knows what you want to watch, or how ChatGPT can answer your questions, or even how self-driving cars can see the road? All of these are powered by something called artificial intelligence. And now everybody in the world is talking about artificial intelligence. But I want to break it down to the points which matters the most. So in this video, I will break it down to you from scratch so you can understand what artificial intelligence is truly about. You will not directly understand how ChatGPT works, but we will get into the topics, into the concepts. In this video and in this series, we don't code, we don't need math in depth. It's just to understand how the core ideas truly work. And you can go to a conversation and know everything about artificial intelligence beforehand. So let's dive right into it. So here we are. What is artificial intelligence? The idea behind artificial intelligence is that a machine performs tasks that normally require human intelligence. The idea for this is like recognizing images, like analyzing different pixels, differentiate between cats and dogs on the other hand. A completely different topic is, for example, understanding language. It's called natural language processing, which we will dive into later. But it's about in different styles, like for ChatGPT, you put in a prompt and you get an answer back in written text. But it's also thinking about voices. Like if you talk to Siri, if you talk to Alexa, you talk with your spoken language and get an answer back in spoken language and not translate it to written language and make a transformation about this. So it's also about making decisions. And an important fact, it's learning from experience. An artificial intelligence system is always not about programming roots, which is the key. It's learning and adapting to a specific problem on in mind. For example, if I have the cats and dogs examples with the images, it's not about saying, oh, the cat has a tail which is a bit longer than dog's tail usually. So if I see a long tail on the image, it should be a cat. This is not the idea of artificial intelligence because we want to learn from this problem, see maybe some images, give the machine some images, and the machine needs to learn from this and differentiate between cats and dogs without predefined rules. So what do I mean with the machine in the end? Machine can be everything, like it can be your computer, it can be your smartphone, somewhere where an algorithm is executed, which we'll see later on how this is really done, um, to make those predictions. The prediction is the outcome and the result. So the whole topic about artificial intelligence is that a system should learn and adapt. Keep that in mind. Before we go to the next part, where we differentiate between two concepts of artificial intelligence. It's the narrow artificial intelligence and the general artificial intelligence. The narrow artificial intelligence is, as already sound in the word, it's like narrow to a specific task. Like, for example, we have a chess AI, which can be better than the best grandmaster, but it only is designed to play games. And not only games, it's about chess. We also have recommendation systems. For example, if you go to a web shop and you get a recommendation for the next product you could buy or buy some products together to get a cheap discount, those models are only for recommendations. Voice assistants, for example, are only for natural language, like Alexa, like Siri. They will talk with you, but they can't play a chess game. So those systems or machines in the end are only designed for the specific task. But the general AI is a different approach, which we see at the bottom. It's at the moment only mostly theoretical, but it's an idea where researchers want to go. It's an artificial intelligence which can learn anything, reasons like human, and adapts across different tasks. So for example, If you have for instance, a patient in an hospital, you see the patient is 32 years old. This numerical value you understand in relation to other ages, how old the patient is, like he's not a child, he is not a senior yet, and you already have an image in mind how old the patient is and how he would look. And these are some completely different tasks because you need to understand numerical values, you need to understand images, and you need to combine those ideas together. And this is the general AI idea, that we can get different modalities and get them work together and reason in the end like you would reason in the specific case. But as I already mentioned, it's mostly theoretical, but it's a way where researchers will go. So let's focus about the core idea. As already mentioned, modern AI follows one concept. We want to learn from data. So instead of writing the rules manually, where we say, okay, if the tail is like 30 centimeters long, we go into this class or into this, we give the system examples. We show them thousands of cat images. We tell the system then which one are cats. Like if we put other images for the different prediction in there to understand, okay, what are the differences to the other M class, we can tell them which one are cats. In which scenario we're doing this, I will tell you on the next slide. Because here the model should learn patterns over time, like about shapes, is there the ears, textures, or other features. Like features are, in this case, important information. I will go to the nomenclature later on, but right now, features are some important information in the data which we want to extract to get a result back. And this idea I described right now is machine learning. Think in your mind, artificial intelligence is the whole topic. And there is machine learning in a smaller circle. And in the end, there's also some more advanced topics like deep learning and other stuff we will go into later. But just have in mind, machine learning is like the whole thing inside of artificial intelligence, which is about the classification models and the learning from data in the end. So if you heard now about machine learning, the next question is, what types of machine learning are there? Like I mentioned you right now, 3 types of machine learning. In recent research, there are always 4 because everybody is mixing supervised learning and unsupervised learning together. It's called semi-supervised learning, but those are more advanced topics. So for the basic, we have the differentiation between supervised learning, unsupervised, and reinforcement. And if you think in mind and combine the first 2 in some way, then you also have the semi-supervised learning. But therefore, we need to understand the basics. Supervised learning is, as I already mentioned, we have a model that learns from labeled data. Like I give it a cat image and tell it, this is a cat. Give it a dog image and tell it, this is a dog. And then the model needs to learn the differentiation. Another example is spam versus non-spam email. In this case, we also put in emails like text, the body, the recipient, etc., the sender, and label the data as spam and non-spam. And the model needs to differentiate between those. But on the other hand, unsupervised learning has no labels. They only have data. So in this case, I would give it emails and it tries to understand, oh, is there some differentiation between those emails which I can think about? So the model has to find pattern on its own. For example, in a web shop, we want to group customers into segments, which are the good customers, which make most of our sales, which are bad customers, which we don't should reach out that often because they don't buy that often. And this is the most differentiation between supervised and unsupervised learning. On the one hand, we have labels, on the other hand, not. A third option is reinforcement learning, which is completely different from the previous two. So reinforcement learning is that the system learns through trial and error by getting rewards or penalties. You have to imagine that it is like something like a game. You're playing Tetris. If you're good in Tetris, you get points. If you're bad in Tetris, you get penalty by playing from the scratch again. So the most example is like training AI to play a game. On the next slide, I have those three categories visualized, where we see on the supervised learning, we have label data, we have a model which makes predictions, we have spam and not spam. Unsupervised learning, we see unlabeled data, a model, it should find patterns. And on the grid, like the X and Y axis, we see there should be the segments of customers, for example, or some dots which are next to each other, like some groups. And the reinforcement learning is we have an environment, we have an AI agent, and we're getting rewards. Either we get a trophy or we get penalties like going to the monster, and the model learns by experience. And now, don't forget to subscribe to the YouTube channel and like the video. Thank you for watching. So, what are the key concepts behind artificial intelligence? I have here some names, which I already mentioned somehow in the video. We have a model, which is a system that makes the predictions. We have the training, which is the process of learning from data. Like we get some points in there, data points, images, etc. And the model needs to adapt to those. How this is done, we will learn later on, but this is the first general idea. Then we have features, which is the important information extracted from data. Like for example, in the patient example, age would be a feature because we can then differentiate between young patients, old patients, or middle-aged patients. And now if we have a look at the last part, which is generalization. It's the ability to perform well on unseen data. Something I didn't mention yet, but it's the most important thing when it comes to the quality of your model in the end. Because this is what we want. If you go to ChatGPT and I'm putting in 10 different prompts and the model can answer all my 10 prompts perfectly. But then you go to ChatGPT, your prompt and the different wording than I would use, and the model can't handle this wording, then we have a problem and you're not satisfied with the model itself. And so in the end, we need something that generalizes well from the data it learns on, like the cats and dogs images, and can perform good on new images or new prompts and adapt to those. Because if we only have gray cats in our training data and on our data which was not seen by the model yet, we have a cat which has a different color, the model still should be able to differentiate this cat from a dog. So in this case, it should not only focus on the color, but you know what I mean from this, because this is what we need to differentiate from manually pre-written rules, because the color I could tell you, okay, take the color, take the tail length, etc. This could be a manually predefined rule. But the quality is that we have the generalization aspect, that we learn from the data and handle well new unseen data. Okay, with those concepts in mind, we have a look at why AI matters. So AI is already transforming the world. In everyday work, we use AI assistants for maybe writing the email better. I'm using them as well, for sure. For example, in healthcare, for diagnosis diseases in early stages, for example, the early detection of lung cancer. In finance, for fraud detection, when your credit card gets stolen, a model can detect if it's in different behavior, spending behavior, different segments where it goes. Yeah, or for example, stock market prediction in the finance sector, then into the transportation sector, the self-driving cars, how they can see the road, how they can differentiate from other stuff, or in research like drug discovery or personalized medicine. Thank you for watching this video. Now you should have a first idea of what artificial intelligence really is, what machine learning is, and the different concepts of those.